Great. I'm going to go ahead and get started. So again, thank you for joining us. I'm Rick Hall, the CEO of Coginiti, and we're going to talk to you about compatible data sets, really a kind of a key issue in this world of lots of data in lots of different places. I'm joined by Bob Mack, Dr. Bob Mack, who's been in the data space for 30 plus years. He probably, like me, doesn't actually like to quote the number of years because it's been a long time. And but seen really every generation of data technology. And actually, Bob and I worked together almost 30 years ago, and in the early days of data warehousing. And we were really brought back in contact as, we found that the platform that we provide and the approach that Bob provides are really compatible. I thought that their work is super interesting. So I asked Bob if he would join us and share what they're doing with these sets. So we're really glad that you were able to be here. If you have questions, you can put them in the chat. I'll try to, since Bob is going to do most of the talking, I'll try to pick up things from the chat. If I miss it, we'll probably have a few minutes for questions at the end, and anything that we miss, a result of that, we'll come back to you. There will be a recording of the session, and if you reach out, we can provide that. Bob's going to talk about a white paper that he's written on the topic, and there'll be a link and an availability to download that, so that will all be available. So with no further ado, Bob, great to have you, and why don't you kind of give us a bit of an intro and tell us what you're thinking about.
Well, thank you for the introduction, Rick, and I'd like to thank everyone that's joining us this morning. As an introduction to myself, as Rick said, I've been working in this area for approximately 40 years now. Many years as an independent consultant. As an independent consultant, I worked for 8 of the Fortune 100 companies, so I'm familiar with large corporations, complex data architectures, and the like. The last couple of years, mostly have been working on business intelligence projects. I've also applied for 10 U.S. patents and been issued those patents on Dataset and data architecture design, implementation, and management. So today we wanted to talk about enriching your existing data architecture to support AI. And as part of this, we're going to do a presentation and a demonstration. You'll see a distributed data fabric in action, so it should be cool. We'll start off talking about the data architecture as it exists today. This graphic depicts that data architecture of individual data sets that are siloed, disparate data sets, right? And this is a world of data pipelines and ETL and data integration and things like that. But the important aspects as far as AI is concerned is that the architecture is very disjointed and fragmented, right? And it has a lot of redundant data in because the silos have their own representations, their own disparate representations of master data, such as products and customers and such. So you have a lot of redundant data, a lot of redundant master data, and poor quality because we're not enforcing data integrity between the data sets. So that's what's impacting us for AI. It's not an appropriate architecture for AI, and that machine learning, semantics, and knowledge graph. All the modern technologies have problems with this fragmented architecture. The other thing is that this is a very difficult architecture to work in. The data sets don't communicate with each other. They don't work together. So we have to go through some extraordinary means to get them to a place where everything is integrated. So we take a different approach at Maxxphase, a different architecture. We take the existing architecture and encapsulate each data set with what we call our data compatibility standards. They're our products, right? And now this becomes a world now of directly interoperable data systems that work together. And the major thing is we're enforcing data integrity between data sets so that we can actually join across data sets and get whatever information you want when you need it. You don't have to do a data warehouse project, right? The data is readily available.
Yeah. And, Bob, I think that that's a really interesting point. Kind of in most of the time that you and I have been in the business, vendors have been saying, just centralize all your data in our big data warehouse and everything will be good, right? But for 30 years, or longer, people have been trying to do that, and it really hasn't worked out. So, somebody mentioned data mesh, and really a large part of this is an architecture which gets to a distributed data mesh, but deals with it across your existing environment, right? And I think that's something that, Bob, you're going to talk about.
Well, the data mesh itself is a disparate, they don't do direct interoperability in data mesh, which is unfortunate. It would make data mesh so much better. But for an agenda, we're going to look at a couple different things. So we're going to talk about the secret of data interoperability, right? And that, heads up, it's a data context, right? So we have two slides to talk about data context. We'll talk about the disparate data context and the compatible data context. When we encapsulate these data sets, they become modular plug-and-play data sets that are analytics ready. So we have a slide on all that information. And then an interesting thing happens when we make these data sets compatible. They actually form a distributed data fabric. So without any extra work, just by making them compatible, they're so compatible, they form a data fabric. And then this is actually a perfect architecture for supporting our modern technologies, such as AI, because it's instead of fragmented, the fabric is seamless, right? We're enforcing end-to-end data integrity across the fabric, so we have much better data quality than what you had in your former architecture. We're also bringing in complete data sets instead of subsets, right? And we're also not using ETL, so we're not modifying the data content, right? We're not adding any bias or corrupting any data that was from the original set. So that's a very important part for AI. And then the other thing is, at the end of this, I would like you to be astonished by how easy this actually is to do. So we're doing something that's relatively simple to enhance the functionality of the entire data architecture. To do this, we have to change our paradigm a little bit about data architecture. So we currently look at each data system separately, right? But with compatible data architecture, you want to look at the entire fabric and then realize that each data set is an integral component within the fabric. And to do that, we use a tool that Rick has developed, which is Coginiti. So if you'd like to talk a little bit about the fabric and Coginiti, this would be a good time.
Yeah, great. So one of the things that, outside of just reconnecting with Bob, as we've talked about what they're doing, I think for many of our users, some of whom are on here today, one of the things is that we access data anywhere, right? So we often think of ourselves as one door to data. So we can talk to all the major databases, whether it's BigQuery or Snowflake or Netezza or you name it. As well as talking to open table formats like Iceberg, et cetera. And we can access those with, every type of data processing engine, from a Trino that might need to join to a join directly between Snowflake and a SQL Server database. That's all great, right? And we're happy that we can do all that. But those joins aren't going to get you anywhere if you don't actually have an integrated data fabric, right? If you don't actually have the same identifier for customer, when you go to make that join, you've got a problem. So it's a natural, kind of fit for us to see a company like Maxxphase and what Bob is doing, which essentially implements this connectivity at the data integrity level across all of those platforms. And it works, of course, great with tooling like ours, which is, designed to access data wherever it lies.
Good. And as I said, we will be doing a demonstration using Coginiti as a tool for data administration. We also will be using Microsoft Power BI to show you the data warehouse functionality that we've incorporated into the standards that we collect. So to start with.
So Bob, just a question, and maybe you're going to cover this, right? But one of the users asked, is this just a data mesh, right? And I think you said earlier that the difference between kind of data mesh by itself and data mesh with compatibility, maybe you could just answer that question briefly.
Yeah, so the data mesh, when you do a data product, it's a disparate data product, right? We don't have interoperability between data products, right? If you actually add the data compatibility standards to the data mesh, now when you form the data product, you get a compatible data product, and you can actually join across them. So today, as data mesh is practiced, no, you're creating data silos, right?
Yeah, right. So that's a really important point, right? So one of the powers of the original data mesh idea was to push ownership back to the domain, right? And when you say domain ownership, you mean local ownership, oftentimes. And local ownership means working with local data. And, you haven't really addressed how one data product from one domain connects with another data product from another domain. And really, that's what you're talking about with this compatibility standard. Is that right, Bob?
Yes, that is correct. So we wanted to talk about the secret of direct data set interoperability, which is the data context. So for definition, the data context of a data set really is the shell of master data that encapsulates the data set. So it's the who, what, when, and where of the data set, and it defines the significance of the data set relative to other data sets. Well, when you have, our independent research has shown that when you have data silos, you have a disparate data context. It's inconsistent. It's not compatible across data sets. And this is an example of the disparate data context that I'm showing on the screen. So we have here three different sources: database 1, database 2, database 3. Right? And this is all from the master data domain for address. So that's location, right? So it's part of the data context. And you can see that we have disparate names, disparate column names. The content is disparate, right? So we have problems here as far as working across data sets. In contrast, compatible data context looks like this. So you see the same three databases, same addresses represented, right? But now it's in a compatible mode. So if we go back, you see this is the disparate mode where you can't relate across data sets. And this is the compatible mode. And now you can see, because of the compatibility, we can easily make relationships across these data sets, right? Mainly because the primary keys are consistent. Okay, so this is a new kind of relationship. It's one of my patents. We call it a pure data set connector, right? And it has a lot of interesting properties, different from what you're used to. So it's an unlimited number of connections. We do primary key to primary key, so you can connect, in this case, we show 3 different data sets connected, right? But it doesn't matter. It can be 30 different data sets. It can be 300 different data sets, right? We can connect all of them together, or any of them together as you use it. They're also plug and play, so it's the fact that I can connect one data set to another data set to another data set, and then at a different time plug them together in a different way. So that's the plug and play concept of all this. As I said, we're enforcing data integrity. So how do we enforce data integrity in this manner? What we do is we have a data registry, right? So a single source of data for all these data sets that we make compatible data concepts, right? So in this case, we have an external data registry. So we take the original data from the disparate data context, send it off to our address validator. They return the matched set, the standardized set of data. We put it into the standardized structure, and that's basically how we do the referential integrity across data sets. So we use an external source for this particular one. And the other interesting part of all this is these data set connectors, these peer data set connectors, form the threads of your data fabric. So this is what weaves these data sets together. So if you have 300 data sets or 30 data sets, whatever, they're all weaved together because of this relationship. So that's data compatible data contexts. We also talked about, I'm sorry.
Go ahead, Bob.
Okay. We also talked about data set modularity, all right? So this is the thing where we encapsulate the data set in our data compatibility standards. So we start with a data set. Now this can be the original data set. It can be a copy of the original data set, right? It can be a denormalized copy of the original data set. So we can do things to, enhance performance and such, but we don't want to alter the data set. We want to make a complete data set because that's what AI is looking for, right? It's not looking for a subset of it. So we bring the whole data set in, make a copy, and then we add our data compatibility standards to it, right? So it's a simple addition of these tables that now encapsulate the disparate data set. And by doing this, we form this compatible data set. Yes, Rick.
So one of the users asked, how does this compare to data virtualization? What I really kind of pointed out to them, and you feel free to add to this, is that virtualization allows you to physically connect, but again, you still have to have compatible data sets in order to make that work. Is that how you would describe it, or how would you answer that?
Something similar. Data virtualization uses what they call live data transformations. So they don't have the data sets being so that you can join across them. They actually do a transformation to make the data sets compatible live, right? Which is what hinders their performance so much. So data virtualization has sort of died down a little bit because it's not as reliable as having direct joins that we do. And of course, it's you're doing data transformation, so you're actually copying a lot of data across your network, and it's causing a lot of problems. So I hope that answers the question. Anyway, getting back to the data set modularity, right? We now have this modular plug and play data set that's analytics ready. Why is it analytics ready? Well, our data compatibility standards are dimensional, right? So we build everything in. So when you actually build this compatible data set, it's now a data mart, right? It's got the ability to do roll-ups, drill downs, slice and dice, all the functions that you would expect in a data warehouse. The most important thing of all this is when we do this standardization, we are not impacting the original data set, right? We do it non-invasively. So this is an add-on to the existing data set. We didn't change any of it. We don't touch your data. We just add to it. We enrich it, right? And we don't affect your data set. We don't affect your existing data architecture. So all that sits underneath what we do as far as data compatibility on top and encapsulating everything. So that's an important function. What we're actually doing here is just adding master data commonality. So the reason you can't query across data sets today is because there's nothing common to join. As Rick said, you have different customer numbers in different data sets, right? Different product IDs in different data sets. We make all that compatible. So now you could join simply across these data sets because of the master data commonality that we added. Now, each data set now becomes an integral component of the data fabric, right? Just by making them compatible, you form a data fabric. It's just automatic. The other interesting thing is if you have multiple companies that use the same standards, now you can do interoperability between organizations. So, for example, you can have a supply chain where you have a supplier and the manufacturer and customers, right? And the manufacturer might want to publish a compatible data set which has all the specifications for their spare parts, right? And the supplier may want to do the same type of thing with the pricing and the availability and et cetera, et cetera. So now the customer can sit there with his AI. He has a problem, the part broke, he doesn't have a spare, he's got to find a spare as quick as possible. He can have AI go out and search for the part that meets those specifications and then go looking for pricing and availability and et cetera, et cetera, et cetera. So it's an ability to go now across data systems. So I think it has some great possibilities as far as supply chain and healthcare and things of that matter. Go ahead,
Hey,
Rick.
Bob. Hey, Bob, you've
Yes.
got a question here, and you maybe are going to cover this, but you did talk about it a little briefly. The question is, how do you track the source of truth if you're duplicating the data? So I think what you mentioned about how this is an add-on to that data is really important to that because you're
Right.
not just updating that data in place.
Yeah, we talk about the truth of the source. I'm going to do a data architecture
Okay, you are
slide
great.
at the end. And the single area truth, well, we call it our golden data fabric. So we add a single source of the truth. It's actually a very good question that was asked. So, and we hope to get to that point. Okay, so for our demonstration of all this, right, this is a compatible data set. So we're doing one of the toughest things in IT, which is a merger and acquisition, but we're going to do it using compatible data sets instead of the regular way of migrating data. Right? So we take a data set, a data cluster from Honeywell, for example, and a data cluster from Novar. These two companies merged a while ago, but the data sets, of course, are fictitious, made up. And we did a simple data set because we want to make it easy. But the idea is you can see there's no relationship between these data sets. There's no compatibility. You can't join across them. So you have disparate data sets, two silos of data. So what do? We add some data compatibility standards to this. So the DCS location table, DCS stands for data compatibility standard. So we have organization location added. We also added an interface table so it's non-invasive, where we draw the primary key out of the business unit table so that we don't have to put foreign keys into this table. So it's non-invasive. We also have the hierarchy here. I'll show you as I numbered the different levels of granularity in this. Oh, I went too far ahead. But anyway, so we have the location coming in from our address validator, so that was external. We have organization coming in from Dun & Bradstreet, and they have their Dun & Bradstreet hierarchy, so that's here. So we have that functionality. We did the same thing on the other side, right? We had organization and location, made them compatible data sets. We also have calendar added into this, as you'll see in the demonstration, but I couldn't put it into this and make it understandable. But anyway, once we get that, now we have our peer data set connectors that we talked about earlier. So we have one for organization. We have a different peer data set connector for location. Excuse me. Now we have our mini data fabric, right, where everything's connected. And we're going to go off to Coginiti and show you how this all works. let's see. So this is Coginiti Pro. I'm currently connected, as you can see here, to 1,028 databases, which is not what I want to do for the demonstration. So I use their filter function, and from that we have 6 databases we're going to deal with. 3 of them are production databases, 3 of them are testing databases, so 2 different environments. I'll show you database 3 here quickly. So this is the original data, right, in these 2 tables, and then we added DCS calendar, DCS location, DCS organization. So all we did to this was incorporate these 3 tables, and these become the anchor points in your data fabric. So that's table or database 3, that's Novar. This is Honeywell. This is the original tables plus DCS counter, DCS location, DCS organization. Right? And then we have a third database here. This is our what we call our data compatibility standards factory. This is where we build the standards. Right. So this is, again, we have calendar, location, and organization, and then some other tables that we use to build the hierarchies and such. We also have up here standard industry codes, which we tie to organization, and we'll show you how that works when we get to Power BI. So just as a quick example, we're going to do something simple here. We have a simple query. We're going to run it. Okay, so this query, if you look closely, comes from the combination of database 1, database 2, and database 3. So we queried across 3 different databases. Can't do that with disparate data sets, right? Because you don't have the links, you don't have the commonality, the master data commonality that you need to do these direct joins. So important factors of this are, anytime you do a join across data sets, now you need to use one of the DCS tables. So that's the anchor points, again, of the fabric. But the fabric contains multiple tables of this. So we used database 1 for this. So now we're going to use database 2, right? The same table in database 2 gives you the same results, right? Database 3, same results. I can even go into our test area and connect across data sets into the test area. So I've got test area connections as well as the regular one. So this is database 2 in our test environment, and of course database 1 in our test environment. So you see what happens here. I have 6 databases linked together by one table, right? I also have other tables in here. So I have location, and I have what did I use here? Counter. I have location, organization, but we'll have to show that different time. So I have other SQL we can go through quickly, but we're running a little late, and I would like to get over to Power BI to show you what this really looks like from a user's point of view. So this is Power BI, right? It's the same 3 databases we have running. This first visual is DCS calendar. The second visual is DCS organization. These bottom 2 visuals are DCS location. And we have up here standard industry codes, which we said was in database 1. This is actually shared. So we added the standard industry codes to the one database, right, our golden records area, and that is inherited into these other databases because of its connection to the foundation or the anchor points. So you can see, even though it's only in a single database and not in that particular database, I can click on energy services here, and you'll see that slice of the data warehouse. I can click on aerospace, and you'll see that slice of the data warehouse, right? I can also go into the organization and click on one organization and see that slice, right? I can also go to location and see that slice of data warehouse, right? I can also go up here to calendar, and let's see, we can roll this up. and I can do the quarters, right? So there's one quarter, or I can do multiple quarters, right? So it works exactly like you would expect a data warehouse to work, but it's drawing the information out of three different databases, which is really kind of cool.
Yeah, and that's really interesting, Bob. So what you're saying is you're taking these databases as they exist, not connected, maybe from a merger, maybe even just departmental. You're creating this factory structure to create the compatible standards, and then you're
Mm-hmm.
adding that standard to each database. And having done that, then you're able to join across them seamlessly. Is
Yes.
that, yeah,
Yeah, that's what you're seeing.
pretty cool.
So,
And
all
of course, I
right.
love the fact that you've done it with our tool, but it's the logic that is really great.
Well, I need the connections that you guys provide, to the different. Now, obviously, with SQL Server, it didn't matter as much, but when you have Oracle and you have SQL Server and you have all these different things, you guys provide that connectivity, and I just provide the joins across the data sets. So it's a thing made in heaven. Okay. I have to go back to the slideshow, and I wanted to show the architecture of all this. Uh, so this is what we talked about. This is the best architecture we've been able to do today. So we have the distributed data architecture, but this one is the golden data fabric, and we'll tell you why in a second. So there's two parts of the data architecture, as you mentioned. We had the data compatibility standards factory, and then we have the distributed golden data fabric, right? So and of course we have our sources on the left-hand side and our data consumption on the right-hand side. And Coginiti is behind all this because we need access to all these different databases and data sets that you'll see. So in the factory itself, we have these areas of master data that we need to standardize, right? So we have defined sets. We have three different kinds of registries essentially. Defined sets are, for calendar, you already know the number of days and all that stuff. So that's all set and straightforward. So we know the complete data set. In the internal registers, we have, for an example, we have product as an internal registry and a chart of accounts as an internal registry for the enterprise. Right? And then for external registries, like we said, with location, we go to our third-party validators and use that as a registry. And we also used organization, so we did Dun and Bradstreet. We had, interaction with them, but that's how we build the standards for our data fabric.
So Bob, you could use external registry, like your example of Address Validator or Dun and Bradstreet, or you could use a tool like an entity resolution tool that create that standard, or you could have an internal source for that. Is that kind of what I'm hearing you say about these?
Yeah, yes. Internal source, you'd have to set it up yourself as a registry, but that's what enforces the data integrity across the fabric, right? So it's an important part of what makes all this connectivity. So there's in the golden fabric, we have three different areas to talk about too. We have the foundation, which are, well, as you'll see, the data sets that come in. So we have the data sources come in. We encapsulate them within the standards that are produced in the factory, and now you have your compatible data sets. We also have, that's structured, but we also do unstructured data, and you can make them compatible and add all the functionality that we add to the standard, the structured data sets. So now we can connect structured data sets to unstructured data sets. All right, can do all that. The part that makes this the golden data fabric is what was the question that was asked. We have this compatible golden record. So in our standards, we still have some redundancy of the data, right? And we want to take that out. We want to have one source of one source of truth for each master data subject area, master data domain that we're managing, right? So we have, for example, here, this would be equivalent to product 360, right? And this would be customer 360. Yes,
So,
sir.
Bob, there have been a couple of questions about how do you deal with changes, right? So the master data or the data set that's your registry might change, or new data comes in to the operational system.
Yeah.
Can you talk about that?
Well, a couple things we can do here. In this golden data records area, we can put logs behind all these. So we can do chronological records, recording of how data has changed, how the master data has changed over time, right? And we can also do things in the structured area. So if you have a change comes through, you get an update. Now you have to send out to, let's say it's a change of address. We have to send out to um, the address validator and update it, get a new standard for that new address. So we just add to it. So the data, once you make it compatible, stays compatible until there is a change. And then when there's a change, you just handle that as a one-off, change to the data set. So we handle
So
all that.
in an operational world, would that be running as kind of a real time activity that new data comes in, you
You
run it
could
through these
run it real
standards?
time. You can run it as batch. Yeah. A lot of these address validators, they actually have real time. They have type ahead and all that fancy stuff that, so you can use. So once the data gets committed to the database, we can trigger off a go out and get the standardized address and then implement it. So yeah, it's extra work, but yeah, you do have to deal with the changes that happen over time. Yeah.
So you
So
can implement this both as kind of a this mesh data warehousey kind of fabric where you do it as you need to. Maybe it's overnight, but you can also do this in real time so that you can be adding this directly
yes,
to these operational systems.
right. So I mean, you originally do it as a match to a null, right? To say that okay, we need to trigger this off and get this address validated, and that's how you do it. So it doesn't have to be real time necessarily, but you can do it that way. All right. So we were talking about the golden records area. So we have, like I say, product 360, customer 360, et cetera, et cetera, et cetera. And all these, of course, are now compatible data sets, so they can be used in conjunction with anything down here. So you can even do like Facebook and look at the customer's Facebook account, for example, things like that. Or, if you have information from Facebook that's related to customer. And then the other area, which is really kind of interesting, is this third area, which is our compatible use case sandbox. So you can take information from here, for example, from the base foundation. You can materialize a view, right, which would be a data warehouse for, let's say, key performance indicators. So you could have a data warehouse here for key performance indicators that actually comes in from your compatible data sets, right? And then you can do another one here. So if you want to study churn, why people are you leaving your getting competitor services or whatever. So you can take the customer subset of customers that have left and build that into a data set, right? So for machine learning purposes. Right? So you can take that and you can actually combine back into any of these data sets from this subset of customers, and you can do machine learning on it, and then you can do your scoring back into your customer golden records area if you want to use in using AI to find the tendencies and look at for propensity for people changing services and such. So, and then of course, well, there's all kinds of things you can do in here, but these are different things you can build, but it's easy to build because you do it as a materialized view of the original data sets. So we're not really transforming the data in the sense of what we're doing today for data integration, because we don't really have to transform it because we've made it compatible just by hitting the data context of the data systems.
So I think that's really interesting, Bob. And if I understand it correctly, that's a big part of what's different about, kind of how things are often done today, right? So kind of the classic data warehouse. You do all that transformation as part of your ETL or your ELT process, either one, right? Or you say you want to implement virtualization, and then you're going to do that transformation kind of on the fly as part of that join, which creates all those processing overhead. Right. So what you're saying is you're going to start with a world that says, okay, I've got 2 or maybe N different systems. They exist already. They have incompatible data. So you say, okay, I'm going to implement this approach. And you say, which type of data? Maybe it's a calendar, product, customer, whatever, right? Then you develop this factory where you're saying, I'm going to develop the data standard for each of these data sets that I want to be able to make compatible. Right. And then I'm going to add that into my operational systems without changing anything in the architecture of those systems. Right. And then now I'm available for joining and processing across these data sets and doing it without this on-the-fly transformation and without a big ETL process to do it into a data mart. Is that right? Is that right?
It's just a lot simpler to do this than to take a complete data set and transform it. Now, I mean, that sort of thing can take years, where this takes a matter of days, to bring a data set up to being compatible. So, and these standards are all reusable. So every interface in here between these, 300 data sets, every interface is the same. Each data system connects to each other data system in the same way. When you're doing data virtualization or ETL, you're doing all these handcrafted interfaces, and they're all different, right? And that's where you lose. That's where you lose the battle against this, because it's a battle of scale, right? We're doing a whole lot more work when you're doing data transformations. And then the whole point is, AI doesn't want those transformations. AI wants to see the data that was originally collected. It doesn't want to see what you transformed it into or what subset of the data. It wants to see the whole thing. So that's why I say this is much more appropriate for AI than what the current data architecture is.
So, Bob, you can do this within a company. If you have partners who want to exchange data, could you make that registry available across organizations?
Yes. Yeah. That's the whole point. The thing about using the third party is it's a more global registry, right? So multiple people can get into address. So if everyone uses the same address validator, right? Different companies use the same address validator. It should end up with the same standard. Right? I mean, you can also check across systems because you can look at the standards, right, and make sure that it matches up. But yeah, and then you can join across systems. So we want to start doing things now where you have large data warehouses of information from multiple companies for healthcare and things like that. You can never do that with data integration because it's a bottleneck, right? The more you put into it, the slower it gets. In this case, we're doing all these things independently. One data set's not dependent upon the others. You just make them compatible independently of all the other data sets. So there's no bottleneck in it.
Great.
Okay. Did we have any other questions?
I think you've been answering them as we go here, right? So okay. I'm sure there's some of them may end up with some technical feedback. So we've got these folks. We'll share the questions because I know you're actually not looking at them, which is fine because I am. No, I'm translating. Yeah, I'm translating between what they said and your answer. So we'll share all that contact information and you can follow up on some of that detail should you need to. And if there are other questions that we haven't answered, please feel free to put them in the chat.
Yeah, we actually have some time left. We can talk about how people get in touch with us and how we tend to engage customers that are interested in data compatibility. One of the things we talked about the white paper, and we have the link to the landing page for the white paper here. And this, of course, is an image of the white paper. What we would like to do.
We've just dropped the white paper link into the chat for
Okay.
anybody who wants to just hit that URL directly. And of course, we'll share it as well
Yeah.
afterwards.
So how we normally get, customers call us with use cases that are difficult to do with data integration, right? So that's how a lot of this gets started. So we've talked about, spare parts and, having to deal with manufacturers with different information with the suppliers and then customer. We've also dealt with a marketing organization that actually does one channel of marketing, right? But it does it for multiple clients. But the organization doing the marketing doesn't know what the client's campaigns and all the other stuff are and what's happening in the other channels. So they want to be able to transfer this information back so that they can put it into their warehouse and see what impacts it has overall across the marketing channels. Right? So that's another one we've dealt with.
So Bob, if folks are interested in this and they want to figure out whether you can help them, they can get in touch with you just by info@Maxxphase,
Yes.
and you can come in and do kind of a review or an assessment to help them figure out how they do it. Is that the kind of way that you would work typically?
Right, that's another way we do it. We do an assessment if they want to have a couple different systems assessed. We do a data model part of it. We look at the model. We determine what standards are needed for their data sets. And then we can give them pricing and approximately how long it's going to take and what's involved and et cetera, et cetera. The other thing we found is people want to do a quick proof of concept, and some of these can be very short, a couple weeks, and and others are a little bit longer. But the whole thing is they want to see how this works with their data sets. So we've done some work in that area too, and that's.
Yeah, go ahead. What I was going to say, Bob, is I think one of the things that you said early, which I think is we see that in Coginiti's customers, is that they've built these data architectures over many years. They've been struggling perhaps with kind of the data warehouse type of architecture purely, and even when they're applying AI, historically it's been I'm going to do that specific optimization, say, for pricing. And they can kind of, push that data set together for that particular use case, maybe with brute force. But now with language models, people want to oftentimes ask a question which maybe goes across the business broadly. They don't know that question in advance. So now you have to actually think about data compatibility at a much bigger, almost an enterprise scale. And I think what's interesting about your approach is what you're saying is you don't have to put all that data in one place to do it. You don't have to build a giant set of transformations. You need to establish this registry, figure out which approach you're going to use to the registry, and then add the registry information to your existing environment, and then away you go.
Yeah. And the other thing is you don't want to transform your data, right? As far as AI is concerned, because when you transform your data, the only thing we can really say is that you went from a source data silo to a target data silo. You can say that the two data sets are no longer equivalent, but you can't join them together to say how they've changed. You can't even say, what kind of hallucination you're going to cause because of the transformation. So you want to have the data in its own altered form for AI, right? So data warehouse was done so that we could get reports quickly, which is great, but it wasn't designed to handle AI and the semantics and knowledge graph and things like that, because it's changing the data, right? It's transforming the data.
So those transformations often doing aggregation, so the human, like you and I, can interpret it. But in your AI case, the AI engine probably wants to look at all the granular data to spot trends that that we might have missed or do whatever it's going to do.
Yeah.
And so that's kind of a different architecture. And in your world, what you're saying is, hey, just to add the compatibility back to that granular data, and now you're going to be AI ready.
Yeah, it was really a design flaw that caused the problem in the first place, that caused the data silos. So we're actually adding back to the data silos this compatibility that was lost when the data models were converted to physical models and then implemented as silos. That was never really the intent, but that's what happened. And now it's biting us in the butt because, we don't have what we thought we had originally, right?
I think I remember when you and I were working together, and I'm dating us, but it's back when the divestiture of AT&T was going on, right? And
Oh, yes.
they had hundreds of systems that spoke to each other in some Rube Goldberg kind of manner, right? And they were never ever going to get to one compatible data warehouse. So this kind of approach, even though perhaps we didn't have it at the time or I didn't know about it, would have saved a lot of headaches that were going
Yeah.
on.
Yeah. Yeah. I mean, AT&T, they actually got rid of their computer services group and bought NCR, if you remember at that time, and then later on spit out NCR. So, and AT&T got away from the computer business a little bit.
Yeah. Yeah. Great. Anything else that you want to talk about, Bob?
I'd just like to thank everybody for joining us and hope they enjoyed the presentation and get in touch with us, ask us questions, give us use cases. We love it.
Yeah, great. So, Bob, really appreciate it. And of course, we're super happy that you're doing this using the Coginiti tool set. As we said, there's a link to Bob's white paper. Go ahead and feel free to register and get a copy of that. If you have questions, you want to go directly to Bob, info@Maxxphase. If you want to talk to us at Coginiti, of course, info@Coginiti. Either way, we're happy to chat with you. We super appreciate your interest, and we hope that everybody has a great afternoon.
Thank you.